All right, so let's look at an example of doing a normal approximation to a binomial distribution. And you only have 4 of these in your homework. They're all pretty much the same idea. You have a really annoying stapler that seems to randomly jam. On any given attempt to staple, it seems to independently jam 16% of the time. All right, so in a binomial distribution, our P is 16% or 0.16. We've got that much from our first sentence. All right, now part A. Out of 260 papers stapled, what is the probability that your stapler would jam 34 times or fewer? All right, so we have N is 260. That's the number of trials we're going to have. And we're interested in an X value of 34 times or fewer. So I've brought this over to a page so we can see P is 0.16. That's our rate of success. N is 260. And then we have an X value of 34, but we're really interested in the probability being less than or equal to 34. 34 or fewer. Okay. So if we think about 34 or fewer, this is a discrete probability distribution. So our numbers can only be 0, 1, 2, 3, and so forth, all the way up to 34. So we're looking at the probability of all of those values up until 34. Because our binomial cumulative table that we've used before doesn't necessarily have all the different values we need to be able to look up, we're going to use Excel to find the answer. So we're going to use the binomial distribution first. So we're going to type binom.dist, and you'll notice that it pops up with one that says dist and one that says range. And since we are looking for a range, all of those values less than 34, we're going to use the range function. I'm going to try to move this over. There we go. All right. Number of trials is 260. Probability is 0.16. And our range is from 0 to 34. Everything less than or equal to 34. So 0 to 34. And I'll hit enter, and there's my probability. Now, what the exercise doesn't tell us, that I want you to kind of take note of as you do these 4 problems for your homework, is we want to round this to 2 decimal places, and it doesn't say that in the exercise. So 0.11 is what I'm going to put in here. 0.11. Now, that's actually our probability using the binomial distribution itself. We're going to move on now to using a normal approximation of that binomial distribution. First, we need to find the mean and the standard deviation. All right, so notice we have 2 blanks for those. So let's go back to our page again. And let's recall from our previous chapter on the binomial distribution that the mean mu is the calculation n times p. All right, so for us, and I'm sorry, my dog is yelling in the background. It's 260 times 0.16. And that gives 41.6. All right, now let's find the standard deviation. Okay, so our standard deviation is the square root of n times p times q. And remember that q, I'll put it up here, q is equal to 1 minus p. So for us, it's 1 minus 0.16, which is really 0.84. All right, so let's fill in to our standard deviation. We're going to have the square root of 260 times 0.16 times 0.84. Oops. And then we can put that into our calculator. All right, and for this, we get 5.911345025. Okay, now in the My Open Math homework, they do want you to report both of these to the number of decimal places that you get. So let me go back here, and I guess I should write these down so I don't have to go flip-flop back and forth. So for our mean, we'll put the 41.6 in, and for the standard deviation, we'll put 5.911345025. Okay, now, does the normal approximation apply? On that web page that I sent you to about the normal approximation to the binomial distribution, you had to make two calculations. You needed to show that n times p was greater than 10, and we had to show that n times q was greater than 10. Okay, so for us, n times p is actually the mean, so that one is certainly greater than 10. And let's do n times q. So if we go back over here, n times q is going to be 260 times 0.84, and that ends up being 218.4. So certainly that's bigger than 10, but let me fill in over here. And so 218.4 is certainly greater than 10, so yes. And it says explain, but it really means this right here. That's our explanation. Those two things are greater than 10, so yes, we can do the normal approximation. All right, so now let's go down to D, and we'll do the normal approximation to find the probability that our stapler will jam 34 times or fewer. So we're going to do the same probability that we did up here, but we're going to use the normal distribution to do it. All right, so let's go back. And remember, with normal distributions, we have z-scores. So on top of our z-score, we have x minus mu. So for us, 34 minus, and our mu was, let's see, 41.6. And then we divide that by the standard deviation. All right, so on top of that fraction, I get negative 7.6, and I still need to divide that by the standard deviation. And that gives negative 1.28566,341. Okay, so now that's our z-score. We need to plug it into Excel to get our probability. And I'm probably going to use most of that number as I plug it into the Excel formula. Let's see if I can move that over so we can see the number. And I'll just go equal norm.s.dist negative 1.28566,341 true. And there's our probability. Now remember that I said earlier when we did the probability in the beginning of the problem that they were rounding these to 2 decimal places. So if we round 0.099 to 2 decimal places, it becomes 0.10. All right, so let's put in 0.10 into here. And now we have the entire question. And there it goes.